Given this equation, x squared over 4 plus y squared over 9 plus z squared over 25 equals 1. And our goal is to visualize this in 3 dimensions. And the tool that we're going to use to do that is to visualize it in 2 first by examining the different traces. So we're going to start with the xy trace. What that means is the z is 0 there. So if z is 0, where is the curve intersecting the xy plane? If the z is 0, we have x squared over 4 plus y squared over 9 equals 1. And what does that look like? That is an ellipse. In the x direction, it goes out to 2. And in the y direction, it goes up and down to 3. So our xy trace is this. You think of the xy trace as being the floor of that surface. So if we're drawing this thing, typically this is considered the x direction, this is considered the y direction, this is considered the z direction. So consider on the floor, we're going to have some sort of an ellipse. Can you visualize that? Again, out to 2, over to 3, here. That's our xy trace. Now let's take a look at the xz trace. So you'll see the xz trace is going to represent what is happening on the left side of this frame, where it's intersecting that. So the xz trace would be x squared over 4 plus z squared over 25 equals 1. Another ellipse. So x out to 2 and z up to 5. So much skinnier in that direction. That's what that trace is going to be. And this gets a little harder to visualize as we're putting these things together. So we have an ellipse on the floor, and then we have an ellipse on the side as it's intersecting that wall, but going on both sides. And then that, of course, was the xz trace. And then we'll finish with the yz trace. So that's the front of this box. What is the yz trace? Y squared over 9 plus z squared over 25 is 1. So again, we can draw yz. You'll see y is out to 3 and z is up and down 5. So here's y, here's z. So y is out to 3, z is up to 5. And then we're going to connect this one. Can you see how all of these things fit together? So here's our graph on Desmos. X squared over 4 plus y squared over 9 plus z squared over 25 equals 1. You can see this thing looks like a football, a tablet, something like that. Now, can we see all of the traces? Let's take a look first at the xy trace. X this direction, y that direction. X out to 2, y up to 3. That's our xy trace. If I look at it forward like this, that's the xz trace. We see the xz trace. X out to 2, z up to 25. And then how about the yz trace? Looking at the yz trace, looking at the yz plane, again, y out to 3, z up to 5. So that's what our graph looks like. You can see all 3 ellipses come together. We have an ellipse in the middle of this pill. We have an ellipse going this way, as well as one coming that way, a little harder to see. So those 3 ellipses are the traces. As we change the numbers downstairs, that will just change how it's stretched. Notice currently z is going up to 5, down to -5. If we change this to 1, what's going to happen? Right now, z goes up to 1, down to -1. Change it to 16, up to 4, down to -4. Similarly with the y, if we want to have a lot more range in y, you could change this y to 36, for example, And now what's happening? Y is going out to 6 and back to -6. The choppiness here is indicative of what? The fact that we lost our frame. It went beyond the frame in that situation. So as we adjust the numbers downstairs, we originally started with x squared over 4 plus y squared over 9 plus z squared over 25. How do we determine what that is going to look like? We consider the traces. We have an ellipse in the xy plane, an ellipse in the xz plane, an ellipse in the yz plane. Put all those ellipses together and we get something called an ellipsoid. So this is an ellipsoid with ellipses in each trace. And this is one of our quadric surfaces. And this is how you spell ellipsoid, Ellipsoid.